So hi, I'm Ayushi.
Hi, I'm Aaliyah.
I'm Fion.
And I'm Krishna, and our project is going to be the ethical considerations of genetically modifying cows to reduce the effects of climate change. Next slide. So first and foremost, we'd like to talk about, I think we need to go one slide back here. We'd like to talk about climate change as a whole. Over the last couple centuries, we've seen a sharp increase in the global temperatures across various organizations. So this here is from the NOAA, and they have given us a graph of sort of the average temperatures from 1880 to 2020, where the blue bars will be a colder than average year and the red is a warmer than average year. So if you look from about the boom of the Industrial Revolution to now, we've seen more on average of warmer than average years than colder. And overall, global temperatures have risen about 1 degree Celsius from 1901 to 2020. And this effect, this rising in temperature, is generally known to be because of the greenhouse gas effect. And this is where certain gases, such as carbon dioxide or methane, are released into the atmosphere and trap the sun's UV rays that are supposed to be released back into space. They get trapped in the atmosphere instead, which leads to an overall increase in the global temperature. Of these, like I said, carbon dioxide is one of the big causes of this greenhouse gas effect. Methane comes second at 14% of human-caused emissions. However, methane is much more potent than carbon dioxide because it has 40 or 80 times the warming power than carbon dioxide over the first 20 years after it reaches the atmosphere. So while carbon dioxide is a long-term problem we need to fix, on the more short term, methane emissions are what need to be curbed. Next slide. So our group, particularly looking at cows, realized that cows release about 200 to 500 liters of methane per day, which account for over 40% of the methane production in the atmosphere. And because of the meat and dairy industries, specifically in the United States, there's about 1 billion cows being used. And this isn't a global range, 1 billion cows are being used. And so because of the amount of cows that we need to produce to sustain our food production, scientists have been searching for a way to reduce the emissions of methane from cows particularly, to reduce the effects of climate change. And like I mentioned earlier, over here on the side, the EPA has shown that carbon dioxide, they give a bigger percentage to carbon dioxide at 79% and methane at 11%. Next slide. So in this presentation, we will be discussing the implications of CRISPR-Cas gene editing on cows as a viable means of reducing emissions. We will be considering a couple different topics. We will do the ethical analysis of whether genetically editing cows is a viable solution. And we will consider the following controversies: the effects or potential effects on dairy and beef production after gene editing, and the harmful effects on the health of individuals consuming those dairy and beef products. Next.
We analyzed this issue under the ethical principles of utilitarianism and deontology. And from a utilitarian perspective, such a movement has been proven to have long-term benefits for the health of our planet as a whole, since less greenhouse gas emissions would result in less heat trapped in the atmosphere, which results in less global warming. And deontological theories focus on the right action rather than the good consequences, and it is our moral right to leave behind a better planet for generations to come and not destroy resources. So modifying cow genetic structures can ensure that we will become closer to reaching this goal.
So to really see the implications of CRISPR editing on a particular species or natural process, it's important to understand how genetic reconstruction even occurs with this tool. So CRISPRs are short DNA sequences with unique spacer sequences, and then by using short RNA molecules as a template, Cas makes highly specific cuts in the DNA molecules that can be used to insert genes or modify the nucleotide sequences at the specific cut site. So it's clear that it's a little bit convenient for scientists to use as a tool, and it's a fairly quick process. Next slide. So when used for cow genetic engineering, CRISPR targets the microbes within the cow's stomachs. Modifying these microbes, which are the ones responsible for methane production, has proven to be successful in minimizing the release of this greenhouse gas, but has also served to improve the healthiness of fats in meat and milk, which answers the question of the implications genetically modified cows can have on those that consume dairy and meat products from this livestock. Now, both methane emissions and healthiness of fats in dairy and meat can be linked to cow gut microbial activities, so targeting these microbes essentially ends up killing two birds with one stone. Generations of cloned cows can be created with similar characteristics in terms of reduced methane production, especially since CRISPR can be done in vitro now, which is within the body. So a combination of genetically modified cows and then selectively breeding them has the potential to cut methane emissions down by 50%. Now, genetically engineering cows has not only become popular for the purpose of reducing methane production, but has also been used to modify other physical features. However, with those physical features, unintended alterations were found as a result of this modification and could most certainly occur with modifying methane production. But so far, it has been able to go through FDA approval as these unintended alterations, quote, do not pose any safety concerns for the cattle or for humans consuming food from the cattle. But these unintended alterations, which have been deemed harmless now, could turn in harmful later if different parts of the cow genome are altered or if the process is somehow conducted incorrectly. However, it seems as if tackling the gut microbes reaps more benefits for the cow, dairy, and meat industry, and then global warming as a whole. Next slide. So though alternatives to gene editing include selectively feeding maize-based silage as opposed to grass-based silage and then a red seaweed-centered diet, time becomes a major disadvantage, and modern genetic technology targets exactly what is responsible for methane production, only to effectively inhibit it. Now, all means of methane inhibiting have proven to be promising. However, under a utilitarian approach, it seems as if gene editing is the most feasible approach, as there seems to be less of an opportunity cost when it comes to the compromising groups, as opposed to red seaweed alternatives, because that asks for seaweed to be cultivated in aquaculture operations that could deplete the oceans and cause ecological problems going forward. Mass producing gene editing technology would not have that immense of a compromising group. So additionally, microbes have the potential to adapt to dietary changes as well. So targeting the microbe genome to reduce methane production is much more promising than changing the diet of the cow. One major concern is definitely the reversibility of the process. Now, though CRISPR's effects are irreversible, especially when passed through generations, the reason why they have received FDA approval is due to the harmlessness of lingering effects. However, CRISPR-off has come into the equation, which is capable of removing the chemical tags and silencing new gene expression, which ends up reversing the effects of CRISPR in the specific organism. However, when CRISPR's effects become generational, the changes it brings to a species' gene pool becomes almost as good as irreversible. Next slide.
We received some feedback and questions from the professor in class, like who would benefit from this genetic modification? And it would be the general population along with farmers and the agriculture industry as a whole. Really all humans would benefit from this, since there would be less global warming and a safer planet to live in, especially for future generations. At the same time, some people may be opposed to this, since the genetic modification would not be necessarily labeled as such. So for someone who is against consuming GMOs, this wouldn't be ideal. And there are many health risks that come with genetic engineering, like toxicity, allergic reactions, loss of nutrition. And so there is a generally negative public view of GMOs. And the main concern from individuals is that they don't feel safe because they don't know the long-term side effects of genetically modified cows. Since this is a relatively new idea, there aren't long-term studies done. And in terms of the price, there is a possibility that the price of beef would increase if since it takes more time and resources to produce. And another possibility is that it could decrease if the farmers decide to produce more cows. This would make them more accessible and cheaper. And the last thing to consider is the quality of the meat and milk, and if these genetically modified cows have any health effects on humans, or even if the cows are affected in any way. Next slide.
So in summary, for this project, we've looked from an ethical standpoint, from utilitarianism and deontology. And it is easy to see that the opportunity cost for using genetic approaches is better when we use a utilitarian perspective, because it significantly lowers methane output and it also promises a healthy planet for future generations. In terms of implications, as you see in the developmental process, genetic engineering is not very harmful to the cattle if done right, and it also reduces methane emissions overall um, in preliminary tests, as we've seen. But there are a lot of considerations to be made in terms of animal welfare versus food efficiency, food production efficiency, because there are some routes that the industry could take which would result in very negative consequences for the cattle, for the health of the cattle, if they optimize for food efficiency. In terms of future work, there are a lot of studies going on right now to see how the genetic modifications can be used in a wider range for a lot more changes. One such study in Australia found 39 microbes in the cow gut that were linked to methane production. So, as we've seen in the developmental process, uh, targeting these methane producing microbes greatly reduces emissions. So, the study has concluded that using CRISPR to target these microbes and kind of weed out the ones that produce a lot of methane reduces emissions by a lot. In addition, adding up to 3% seaweed in a cow's diet has been shown to reduce emissions by about 80%. But this is like a stopgap solution in a way, because only some places have done this and some seaweed is only shown to be effective. So we don't know how other kinds of seaweed around the world would affect cow methane production. And also in terms of generalizations, sheep also release methane. So if cow methane emissions have been shown to be reduced by this work, then maybe we could use this to also reduce methane emissions from sheep as well. And lastly, genetically modified beef could be on the market in the next few years. There's already there's already like genetically engineered salmon that was approved by the FDA in 2015, which made this kind of stuff very easy to get approved. So we could be seeing more genetically modified meat on the market in the next few years. And yeah, that was our presentation. Thank you for listening.
Hey, thank you. Thank you. It's a very, very interesting topic and a very, very nice presentation, all of you. Okay, let me start asking a few questions. I mean, this is not my area. Like if you talk about fake news, I know a lot more than Cal. So I will ask some simple question to just get myself understanding the situation. Okay, so number one, when FDA approved the GMO for salmon in 2016, right? That's what Shriran,
Yeah,
you mentioned that
I,
at the
I
end.
believe it was 2015.
Yeah. So what did they modify? Do you remember for the
Yeah,
salmon?
so for the salmon, what they did was they inserted a growth hormone that makes them grow faster. So what it does is it cut down the growth time of the salmon from 3 years to 18 months.
Wow, that to me is even more harmful than the cow. It's a different reason, right? We actually
Yeah,
modify so they grow faster. Here, we're trying to reduce the methane uh, um, emission by 50%, right? Okay, wow, that
uh,
that's actually good. So for for salmon, if this is from GMO salmon, will when I buy it, when I bought the product, would I see the label in United
yes,
States?
I think they did say that the salmon that they sell will have the GMO label because it's not as widespread um, as other like normal kinds of salmon. So for now, they
Right.
kind of label it. Uh,
Okay.
but also, like anything, they still don't know. Like they have done testing, and apparently, like the GMO salmon might end up suffering from a lot of health problems, but they're not really sure about that for now. So yeah.
Yeah, I don't know how much GMOs salmon I already ate for the past few years since 2016. I'm pretty sure that it's interesting. I'm glad that I'm here to learn about cow, but I learned about salmon as well. Okay, that's good. All right, so let's go back to the cow. So having the story about how FDA handled the fish, I feel positive that this shouldn't be a problem just because of GMO, because we have done similar things before. My next question is, how about international? It's just US, we have to pass GMO, but how about other countries? You mentioned Australia. Australia already done that?
I believe they're doing a bunch of studies in Australia, but as far as I've seen, only the U.S. has like a very kind of long and painful process in terms of approving GMOs.
Okay.
I
From
believe
how?
other countries have like much easier processes, and they do a lot
Okay.
more studies over time.
So US is actually leading in this space right now.
Yeah, in a way,
Okay, in a
because
way. So
it
if
took it took them 2 decades to approve the salmon. It was a long thing.
oh, it took 2 decades
Yeah,
for
yeah.
salmon.
That's
Okay,
why it was such a big breakthrough for other companies because once they approved it, the process was a little bit easier for other people.
okay, okay. That's good. Okay, so I think politically we're seeing I feel optimistic that this technology might actually carry out in, as you said, probably next 10 years, we'll be seeing
Yeah.
this. Okay, so now let's actually go to the core of your report. There is a few issues you mentioned, which I think it make a lot of sense. It's you compare various solutions, including red seaweed, which I I I learned from last quarter, and the thing is that I think the GMO seems to be more, how do I say that, without knowing the consequence, it's probably the cheapest and the easiest way to actually reduce methane by 50%, right?
Yeah.
Because red seaweed is also reducing by about 50%. So they're essentially achieving the same goal, but probably easier because genetic modification is always much faster to occur. Okay, all right. So that actually turned me into the ethic related question. You use both utilitarianism and deontology to analyze the situation. What do you think? I know it's not clearly because you mentioned a few concerns that in your slide. But my question to all of you is that which of the concern in your mind is the most critical one?
Go ahead, you first.
Okay. I was going to say like the health risks that may come with it, just like the loss of nutrition, the toxicity. Some sources say that like genetically modifying stuff also like causes cancer. So just like the health risks that come with it, that would be the biggest concern.
Can I respond very quickly? How will you compare the risk introduced by GMO to the cow versus we're feeding corn to the cow? I mean, is that even comparable about their health risk? And by the way, we're feeding cow as now GMO corn, not just regular corn. We're feeding essentially all the corn. I would say not all the corn, but a huge percentage of the corn are GMO today, right. And we're feeding those corn to the cow we're eating today. And which one actually we think it's a risk more? It's a hard question, but just
if I may.
Yeah, sure. Go ahead.
So from what I remember from ecology, when you feed an organism GMO-based products, that tends to build up in their system more than if they themselves are genetically modified. So it may be that because we are not fully involved in our cow production process, that we're not recognizing that even the cows that eat GMO corn contain genetically modified organisms. So it's more of a public opinion question than a question of the effects of GMOs in that standpoint. That makes sense.
Yes, Krishna, I think you're right. I like your answer that it's actually more of a public opinion issue, and we have a lot of unknown things to resolve in the scientific side about how the whole ecological system is actually going to being altered by the GMO. Yeah. Okay. What other issue? I mean, I think Aliyah mentioned the health risk. Are there any other concern which you think is actually very critical? Or maybe health, you all agree.
Personally, I think
risk.
price.
Okay, price.
Yeah, probably.
I think price is a very big one considering the state of the economy and how many people consume beef and dairy products, especially in the United States, to where if it increases, it's going to be a massive food shortage for a lot of people, not in the sense that there isn't food, but the sense that they cannot obtain that food.
Oh, so you think that the whatever using CRISPR to generate the cow is going to increase the price, or at least increase?
I think.
Yeah, go ahead.
I think there may be an increase for a little bit, just considering like how corporations, if they were people, think, in a sense of maximizing profits. If we produce cows that can release less methane, there is a chance that instead of trying to reduce the effects of climate change, they instead, okay, we'll just have 3/4 of the emissions that we had before, and not completely cut it down to 50%. So we produce more cows, but we're making more of an effort. So we're going to increase the price. And if there is a loophole way that introducing CRISPR to cows causes an increase in price, I'm worried about the individuals that will not be able to get the food that they need.
That's
think-
good concern. Yeah, go ahead.
I think another
That
part of this is
Go ahead.
that usually, like in other countries, the government subsidizes subsidies. Yeah, so they give subsidies to the companies that research for GMO kind of stuff. But in the US, that's not usually the case, which is why you see an increase in the price, because they're just trying to get back the money that they spent in the research. So that could also like be a factor in terms of like the price increase and why it's happening in the US, like more than other places.
Shiren, for some reason my whatever you said got cut off from my end. What did you say about US different from other countries?
I was saying that other countries provide subsidies for GMO research in some areas, which tends to keep the price down when the product actually comes out, because the company doesn't increase the price too much to kind of get back the money that they spent in the research. But in the US, it's a lot less common to see companies get these kind of subsidies, because something, I think mainly because of public opinion and some other factors, which is why we see a lot of price increases when GMO products actually hit the shelves.
Okay. I just want to inject a little bit bias, personal opinion on the price issue about beef. Comparing to my experience with the European meat or beef I can purchase versus US or versus other country like Japan, I feel US, the price of the meat is relatively cheaper, has been relatively cheaper than the country I just mentioned, Europe or Japan. But the quality of the meat in Europe or Japan is actually higher. I mean, that's just because the way they probably using a different way of raising the cattle or something like that. That's just could be bias. So I actually think about this is I think earlier Krishna mentioned about accessibility, whether you can actually allow people who can afford to purchase the meat. Here's what I'm thinking is that okay, I think that is a good issue to talk about fairness, about we can have people to actually access the food they really need to have. It's almost like some of the basic right that we have as a society member. But the other issue which I want to throw in here is that with this technology, because methane will get cut down large scale, 50% is huge. If we actually deploy, assuming we solve all other problems, would that motivate or incentivize people to eat more meat? Means that we are actually going to consume more meat, and the industry is going to be raising 2 billion cattle instead of 1 billion as we have now, because now we got cut down by 50%. Because of the process. What's your thought on that?
I do think that if like they start farming more cattle as an effect to like lower methane production, farming more cattle would probably negate the effect that it was supposed to have in the first place. Like farming more cattle will bring methane production back to what it was.
Right.
So the point is of this to maintain the amount of cattle that are farmed instead of farming significantly more than before, because that would make the whole like point useless at the end.
Yeah, Thank you very much, Ayushi. I think that's a fair point to consider. So here's what I think combined the discussion for the past few minutes. So on one hand, we like to reduce methane. On the other hand, we like to make sure that everybody is going to be paying lower price for especially those people that's actually economically they cannot afford if the price is too high. So here is what I have an idea. I want to throw it out and see how you will respond to that. So I like to install a sensor inside the mouse or inside whatever near every cattle we have. It's a small sensor. Maybe we embed it into to have a cow dentist to embed a sensor to actually detect from the lifetime of a cow how much methane it actually produced. And the thing is that that number will go with the meat. So essentially, the customer who pay to buy the meat is going to pay extra price for paying that methane, the meat release. I mean, some concept like that. It might not be cow dentists do that. There's some other way we can actually do that. So this essentially both help the industry to reduce the per cattle methane emission, but also put some pressure into the customer who purchased the meat. If you actually purchase more meat, you're actually going to pay for certain thing. I feel it's like a tax thing. In some sense, we have to implement this way is that if a household consume certain amount of meat per year, you don't have to worry about that. You don't pay extra. That's normal. We have allocation for every household. But anybody who actually spend more, then the government is going to take some money because they need to use that money specifically to deal with problems like environmental changes or anything. If in United States, I guess if you say I want to tax it for climate change, depending on who are the governor, and it might or might not work, but we might be able to use that money to kind of balance this few factors together. So what's your thought on that?
I think that's actually a really good idea because we know that the US does have a problem with like overconsumption. So I think this would also help reduce like overconsumption and like it would reduce like the waste of food. Yeah. Anyone else want to add anything?
My only concern would be how would we calculate what percentage goes to each product?
Mm-hmm, mm-hmm.
So
And then,
go ahead.
no, yeah, keep going, continue.
So like, would each carton of milk be like 0.0000% of methane? Because if you think of how much meat and dairy we get from a single cow, I don't think that the number itself on the carton may not look like a lot to the individual that's consuming it.
Mm-hmm. Mm-hmm.
And then
Yeah.
another thing we're going to have to consider is how are we going to mass produce this technology that will like calculate methane from each cow? Like that's a whole industry on its own that is going to have to be accounted for.
Yeah. Well, I know it's kind of complicated to how do you do a fair calculation. It just happened that in this generation where we have now, that we have very expensive technology option for us to do a lot of things about data collection, about in a global scale. I think we have a chance to do that. It's just thinking about the technology is helping us to actually be able to engineer genetically engineer the cow. We will. I think health risk is definitely a number one concern in my opinion. But assuming that is not going to be the issue, or the issue we don't even know, and the genetic cow in 10-year FDA already roll out, then we need to consider that how do we somewhat convince the industry, because my concern is that the industry, especially those those big corporate that's actually handling the cow, they actually will have a problem if they need to put extra cost to actually measure the methane that was contributed by each of the cow, and to actually attribute that number to each of the product, is either dairy product or meat product, and how would that work? So therefore, what I'm thinking is that if they're willing to actually do this part, then the taxing from the meat to the customer who consume it, that portion of revenue will be actually come back to the corporate to actually be able to support the research and development they have for capturing that data. But I think in my mind is that the ecological system works this way in the industry, is that the industry is regulated by the law to actually install those, and the installation costs come from the tax, and then the data they collect need to be transparent, need to be actually released to the government, because the government using tax means government is paying that cost. And so then we have a healthy ecological system that everybody has some incentive to actually make the whole system to work. Yeah, that's what I've been thinking about this subject. I mean, after I listened to your presentation, to me, this is, it seems to me is unstoppable. Do you feel that this is stoppable? I mean, it's basically the industry will go that way if actually the technology become mature, and then it appeared to me if they can work on fish, they can work on cow as well. It's just what kind of incentive that we need to provide for all the party involved is doing their part to make sure the whole result, the whole system address all the concern we have, especially health risk and also the pricing issue as well. Okay. I don't have any other question because I learned a lot from all of you. I just wonder whether you have other comments or you have other questions that you would like to raise at this point.
I had one thing I was hoping to sort of try and discuss. While we can tell that scientifically this is where the industry will go, there doesn't seem to be many major issues with the technology or its effects. I was wondering your opinion on sort of getting it through the government side of things, because we mentioned using like a tax to decrease the amount of methane that people will try to consume. But we've also seen how many of the individuals of government are very much either against or don't understand the effects of climate change, or choose to ignore the effects of climate change because they're in the pockets of some other corporation or company. So it's not just for the professor, but anyone.
Yeah. So number one, Krishna, you know, I'm a professor of computer science. I'm not a professor of political science. So my answer will be very limited in this. I feel optimistic that in United States we're heading the right direction in terms of climate change. But I'm pessimistic about how long it will take to reach the place where that's always the issue. So I think we will have a small victory if we can somehow we can somehow push the direction we're doing. Especially, I think so one of the questions I asked you, how about other country, is that surprisingly, a lot of this kind of technology is usually started with some other country, and their experience kind of push us to actually change in the food. So that's why it's important. I want to see what other country is doing. In United States, I think there's a few things that we could potentially expedite this process. Number one, they need to be some small company try to roll out this kind of product. It's not going to be massively available, but there will be some which will, like a pilot, but FDA need to approve that. If FDA approve that, we have a small scale, then it will be unstoppable at all, because it will grow. The other industry, the customer actually will be brainwashed by the media, and will work that way. Okay. So the thing is that FDA, whether they will approve, is actually very important. So if you think about what FDA approved salmon is, the purpose is it grow bigger, grow faster. It's actually why it's actually helping the industry, because the industry will make money faster for that, the lower cost. So you can see that who is actually driving that is corporate. So I'm a little bit concerned is that how will FDA look at this issue, and I think if we have some smart politician, they try to drive this, and it might happen faster. I'm just faster means maybe hopefully we can get it done in 10 years. But within this 10 years, if some other country, Australia or Germany or South Africa, they actually done some of the work there, it might give a push to the FDA already about, well, how about import? Do we even allow to import such kind of beef? If we allow, then that essentially open 50% of the door to this approval process. Yeah. So we'll see. I do think that I do think that the tracking technology about methane emission or any kind of related concept, that the tracking is very convincing. If we can install this kind of the system, have this data, I think that will help us to push this a lot faster. I think we just lost Krishna.
Yeah, her Wi-Fi has been.
Okay. Yeah. That's fine. Now we can say a lot of things behind her back, right? No, that's fine. Okay. All right. So that's great question. Do you have any other question we can discuss? I don't claim I know better than any of you. I probably know less.
I just
go
wanted
ahead.
to add the climate change and the genetic engineering stuff is most probably a generational thing. So because people in Congress are really old, so they either don't want to learn or they don't care. So I feel like as newer, younger people get into government, this kind of stuff will probably be approved faster, or they'll be more open to this kind of stuff.
Right.
In the coming years.
Right. I mean, I agree with you. I'm actually more hopeful when I look at the younger generation that I know about how they think, how they actually critically considering cases like a climate change, like the environmental issue. I feel the awareness of your generation or even younger generation, you guys have been a lot more sensitive than generation like us. So I think that's that's why optimistically, I think I'm optimistic in the long term. It's just in the short term, we will see a lot of up and down in the Washington, D.C. about how they decide things one way or the other. Hopefully, I'm still optimistic even in the short term because we have a lot of development in technology. It revealed a lot of facts that we didn't know before. And I think this process is going to drive the whole thing. And hopefully all the facts we develop is all helping us to converge in reaching a ethical decision for our society, or for the whole world, or for just there's. So that I hope that addressed some of your concern. Yeah. And we depending on all of you. After you graduate, you will be the pioneer for that. Yeah. Hey, Krishna, welcome back.
My Wi-Fi is being very annoying. I'm sorry.
No, that's okay. That's okay. That's Wi-Fi became addictive this day. It used to be 20 or 30 years ago. We don't have any Wi-Fi essentially, and we still survive. All right. Yeah. Okay. All right. So that's great work, and thank you very much. And please just fix the written report a little bit, and then send it to me. Okay. And I'm going to stop recording. Thank you.